All right, so video number 5 should wind it up. Again, super important in calculus to be able to break up two functions. So express the given function as a composition of two functions such that h of x is equal to f of g of x. So this is h of x. So they want me to figure out what f of x and g of x are. And there's more than one answer to this. There's more than one answer, but I need to figure out, like, so for instance, I needed to plug g into f and get this. So the easiest thing would be to make g of x equal to x minus 5. And then what would that make f of x equal? That would make f of x equal the absolute value of x, because then we would have plugged g of x in for x and gotten that. Like I said, more than one answer though, but that's the easiest way. So again, if we make g of x equal to x minus 5, then what would that mean that f of x is? F of x is 1 over x, because then you would have plugged that into that and gotten that. So again, very important in calculus to be able to break a function into a composition of two functions. All right, now the rest of this is pretty smooth sailing. So the ACT expects you to be able to find a function value given an equation, given a chart. The last ACT test had a problem almost virtually identical to this problem. And then given an equation, which I think is on the back page. So the first thing we want to find is g of negative 6. So notice this is x, this is f of x, this is x, this is g of x. So f of negative 6 is negative 7. So, oh, wait, hold on. Yeah, sorry. Did I do that backwards? G of negative 6 is negative 7. All right, and so then sorry, my dog is doing something funny. Okay, so we're going to do f of negative 6 times g of negative 6. Sorry, I got distracted there for a minute, y'all. Okay, so that is not, that does not say f of g of x. That is multiplication. So we're going to find f of negative 6, which is negative 7, and we're going to find g of negative 6, which is negative 7. So that means the product is 49. Okay. Okay, let's turn this over. We're going to finish this quickly. All right. Okay, this is a composition function. So we want to find f of 13. So this is x, this is f of x, this is x, this is g of x. So f of 13 is 169. So this guy is 169. So now we plug 169 in the g equation, and when we do, we get 158 as our final answer. Now you also need to be able to do it finding a graph, using a graph. And one thing I'm not sure that I've mentioned is that this means the same thing as this. So f of g of 4 means the same thing as f of g of 4. That is not multiplication going on there. So we need to find g of 4 first. So this graph is f of x, this graph is g of x. So g of 4, so this is 1, 2, 3, 4. So this is 1, 2, 3, 4. So g of 4 is, so that is the point 4, comma 4. So g of 4 is 4. So now we need to go find f of 4. 1, 2, 3, 4. So f of 4 is right there. So that's like the point 4, comma 2. So the final answer is 2. All right, let's try that again. Last problem. So that is g of f of negative 2, which means the same thing as this. And I've seen the ACT use both. I kind of prefer this way, but your book likes this way better, so I think your book uses this way more. So the first thing we do is find f of negative 2. So this is f of x, so right there, f of negative 2. So that is the point negative 2, comma 0. So f of negative 2 is 0. So now we go and we find g of 0. So right here is the point 0, negative 2. So g of 0 is negative 2. And we're done for the day.